Yeah, my friends, 2025 was the year when technology stopped just making promises and actually started delivering. While many were still learning about AI, humanoid robots began working, making decisions, and learning independently, with human brains connecting to machines. China sped up the global tech race, and scientific breakthroughs overcame previously insurmountable limits this year. Impressive reality. Carlos Alves closely followed the most impactful advances in science and technology, the ones that are not just interesting, but that truly change the course of humanity. Now let's review the top 10 technologies of 2025. The first part isn't, right? So if you're on the couch, get comfortable, because the future, which seemed kind of far away, has already begun. At least for us here at Incredible Reality. Let's go. It was meant to be just another routine test with the humanoid robot like every day. Within seconds, the demonstration became chaotic as mechanical arms flailed, equipment toppled, and the technician was unsure what to do. There was some fear. I don't think a needle could have passed. A viral video of another Chinese robot at Metre losing control during an experiment has revived old fears. The fear that machines could eventually escape our control. If we even have control over them now, right? The robot in question is a commercially available humanoid capable of performing dynamic tasks, such as running, dancing, and even doing front and back flips. And there are already several videos of users who bought these machines and are using these robots in public areas. It was designed to be multifunctional, strong, and agile for complex environments. However, that impressive strength could become a threat in the future, or even soon, as the video clearly shows. During the test, the robot was suspended by a platform, and when its body control routine was activated. Before hitting the ground, it became physically unstable, thrashing so violently it nearly toppled its support structure. The six-sleeve robot's human operator said the incident resulted from an execution error, a body movement policy that was fully activated while the robot's feet had not yet touched the ground. What this caused was instability in the balance system. It seems like something technical, but the result was visually dramatic. In the video, the robot behaves wildly, knocking over a computer, scattering equipment, and making the engineer step back. He was clearly scared, wasn't he? In seconds, what was just a test turned into a scene of panic, highlighting risks and failures in advanced robot control systems, despite no autonomous decisions by the robot in this incident. Then, this video and others with similar scenes, including one showing a robot simulating an attack on a crowd. Over there in China, it reignites a very uncomfortable discussion. How should we deal with these machines that, even without intention, can pose a great danger to all of us? Combining artificial intelligence with complex biomechanical structures produces robots that learn, react, and adapt. But when that adaptation fails or the programming encounters an error, the result can be pretty scary. Humanoid robots would be unpredictable and have real psychological effects, drawing comparisons to films like The Terminator and I, Robot. Debate over these machines and their safety is increasing. In fact, on social media, it shows that the line between admiration and fear is getting thinner and thinner. Though many of these incidents are blamed on technical failures, they highlight a core challenge in modern robotics. How can we ensure absolute control over systems that operate partially autonomously? Also, how can we protect people who use these machines now or in the future? And what will it be like when these robots are among us by the thousands and acting more and more autonomously in Brazil? A 25-year scientific discovery could permanently change global medical history. Researchers managed to turn a protein found in the placenta into a medication capable of restoring movement to people, even those who are quadriplegic. It's the birth of a new hope. Restoring mobility to people once told they would be confined to a wheelchair seemed impossible until recently. Researcher Tatiana Sampaio, a professor and doctor at the Federal University of Rio de Janeiro, led the achievement with a multidisciplinary team of neurosurgeons, physical therapists, and health specialists. The result of this long work is polylaminin, a substance created from laminin, a protein naturally produced by the nervous system. During testing, it showed impressive effectiveness. Bank clerk Bruno Drummond Freitas received the medication 24 hours after his serious accident. He fully regained all his movements, surpassing medical diagnoses and the team's expectations. To grasp its importance, remember the spinal cord's role. It acts as a main expressway between the brain and body, carrying electrical signals that enable movement. A serious injury breaks this communication, leaving arms and legs unresponsive. What scientists have discovered is that laminin can help neurons build a new pathway, thus bridging the injured area and forming connections to restore electrical impulses. In simple terms, it's like opening a detour on a blocked road, allowing the flow to pass through again. That's the difference with polylaminin. Unlike stem cells, which are risky and unpredictable, the natural protein is already used by the body to regenerate tissues. Brazilian scientists, inspired by nature, developed a simpler, safer, and more accessible alternative. In tests with severely injured dogs, 4 out of 6 regained movement, and in human patients, about 10 people have already shown partial or total recovery of mobility. And the heart of this treatment seems to be in the timing. The most significant results appear when the medication is applied within the first 24 hours after the trauma. But researchers have also observed benefits in older injuries. Another benefit is its simplicity. 1 dose and physical therapy are enough to begin rehabilitation. Let me remove my glasses for dramatic effect. A simple blink of an eye may seem trivial to us humans, but when it comes from a machine, it can be unsettling. You can see it in this image here. Look at these images here. Yeah, that was exactly the feeling caused by this new video you're seeing from the Chinese company Headform, which presented its head. Humanoid robots can mimic facial expressions so realistically, they even fool robotics experts. In the video, the robot looks around with such natural blinking and an intrigued expression that many viewers felt uneasy. A blend of intrigue and oddness. The startup's proposal is clear: to bring humans and robots closer together through emotion, or at least through the emulation of emotion, isn't it? The project is not just a technological curiosity, but a decisive step toward a future where humans and machines will be able to communicate more naturally. If we can put it that way, the startup made it clear that its goal goes far beyond mechanical engineering. It's about building robots that understand nonverbal cues and engage with us. This innovation combines self-supervised AI algorithms with high-precision bionic actuators that mimic subtle human facial movements. Every blink, muscle contraction, and sideways glance were meant to mimic the complexity of human expressions. To understand the scale of this, just remember that the human face is capable of more than 40 different muscle movements, which together form thousands of emotional variations, okay? To make this clearer, consider puppets. Pulling a string makes them smile or close their eyes. Now picture that logic combined with ultra-silent motors, advanced sensors, and an AI brain coordinating everything in real time. That's how this robotic head can convincingly simulate emotions. The technical result is impressive. There are 30 degrees of freedom just in the face, with brushless motors designed to ensure smooth movements, as well as quick response and reduced energy consumption. In addition, the Elf series from the company. Does it really remind you of The Lord of the Rings? It depicts faces with fantastical traits like large, stylized ears, yet maintains enough realism to evoke a sense of strangeness. And it also fascinates at the same time. The most intriguing moment, however, the climax of this demonstration. The robotic head not only mimics human gestures, but also authentically conveys the sense of thinking and reacting. The gaze that follows the environment, the blinking that happens at just the right moment, and the lip sync with the speech all strongly reinforce the illusion of presence. As if you were facing a hybrid being between man and machine, this advancement opens up a deep reflection. If robots can convincingly express emotions, it will change our relationship with machines. Could a future interaction with a robot become indistinguishable from talking to a real person? And to what extent can our perception of empathy be fooled by an artificial system that was programmed and well-programmed? Let's put it this way, what the Headform shows us is that the boundary between the human and the artificial is becoming increasingly thin. Indeed, and maybe sooner than we imagine, we will have robots not only working alongside us, but also living with us on an emotional level, if we can put it that way. A recent video from Robotics is drawing the attention of the whole world. And in a previous episode here on Amazing Reality, we showed just a few scenes. But now they've gone beyond those tests and showed their humanoid robot eye facing not only kicks, but also violent pulls and pushes. The robot survived every impact due to its new anti-gravity mode. The scene resembles an unofficial military training. Engineers push, kick, and even pull Robo by the neck with a rope, but instead of falling and staying on the ground like the old models, The G1 anticipates the impacts, adjusts its center of gravity, and gets up almost instantly, showing movements that closely resemble the reaction of a human athlete. This resilience is possible because the G1 uses depth cameras, 3D LiDAR, and joint motors operating in real time. When a blow hits it, the robot calculates how to reposition its body before falling, thus absorbing the impact with its knees and projecting itself back to an upright position. In extreme tests, it was thrown meters forward but always recovered on its own. This controlled brutality aims to show G1 is more than a technical demonstration. It was built for real environments like factories, labs, and hospitals, where falls and collisions can hurt efficiency. A robot that handles this stress reduces downtime, saves time, and shows readiness for robust autonomous tasks. Researchers from Tsinghua University have implemented the N2 track system in the G1, enabling the robot to track and replicate human movements, even during intense disturbances. This increases its versatility, making it not only a robust platform, but also adaptable to different real-world scenarios. And the boundary between biology and technology has just been pushed a little further. Scientists are growing mini-brains to use as living processors. The Swiss startup Final Spark is using human neurons to process data in a global project, with 10 international universities helping with this project. And it announced the breakthrough of the world's first functional biological computer, ushering in a new era in computing known as biocomputing. The technology uses small lab-grown groups of human neurons, called brain organoids, connected to electrodes to do simple computational tasks. Each organoid has about 10,000 neurons, far fewer than the human brain's 100 billion, but enough to show learning, adaptation, and coordinated electrical response. The idea is both simple and unsettling. Instead of trying to mimic the brain with silicon chips, as we currently do, scientists are now literally using real neurons as processors in the Final Spark laboratory. Those mini-brains are kept alive in nutrient solutions and connected to systems that translate electrical impulses into digital data. When stimulated, neurons fire electrical spikes, which are the biological equivalents of the ones and zeros in modern computing. Surprisingly, some of these systems can already learn through rewards, receiving dopamine when they give desired responses, much like the human brain. This type of biological learning uses 1,000,000 times less energy than silicon-based artificial intelligence. This makes biocomputing a possible solution for the energy collapse that comes with the growth of artificial intelligence models. But keeping these processors alive is not simple. The organoids don't have blood vessels and survive on average for 4 months before they die. In their final moments, researchers observed a neural burst, a final wave of electrical activity similar to what happens in the human brain before death. Despite limitations, this is a historic breakthrough. Final Spark lets universities worldwide remotely access these organoids and transmit neural signals in real time. And what if the very creators of artificial intelligence were saying the following loud and clear? Okay, you have no idea what's coming? This isn't a conspiracy theory or a science fiction movie plot, my friends. This is a warning from 2 major tech figures, Mo Goth, former Google ex-business director, and Geoffrey Hinton, Nobel Prize winner and one of the fathers of artificial intelligence. A year after winning the prize for work foundational to modern AI, Hinton changed his tone. Now he says that the same technology he helped develop may surpass and dominate its creators. He says big tech companies are moving forward very fast, too fast. Competition between countries makes it impossible to slow down. And according to him, maybe the world will only wake up to the danger after a so-called Chernobyl moment for artificial intelligence. A disaster so large it will be impossible to pretend all is fine. According to the father of AI, we're in a technological arms race, much like the atomic bomb era. If one country tries to stop, another pushes even harder ahead. Companies act the same way. This creates a chain reaction. More models, more capabilities, more power, and less time to discuss limits, rules, and safety. He believes that a super artificial intelligence, smarter than any human in almost everything, could emerge in 10 to 20 years. And in this scenario, it's obvious that the question stops being, what can AI do for us? And becomes, will it still need us? So he's pretty straightforward about this topic. And also when he talks about work. That idea that, as has always happened in history, technology destroys jobs but will create others, might not apply this time. According to him, AI is not just automating muscles like in the Industrial Revolution. It's automating intelligence, especially mundane intellectual work, reviewing contracts, answering emails, writing reports, analyzing data. He gives the example that one person with AI can do the work of 5 to 10 people alone. The result isn't that AI will steal your job, but rather that in the hands of a single person, it will replace many jobs. And that's where the uncomfortable detail comes in. Hinton says that careers involving complex physical manipulation, like bricklayers, masons, and others, may be much safer than prestigious professions like lawyers or legal assistants. That's because, according to him, it's much easier to train a model to write a legal opinion than to fix tight plumbing in an old building. At the same time, he warns the following. When it happens, this revolution will drastically increase inequality, creating so-called very unpleasant societies, with a few machine owners getting richer and a multitude of people being replaced. On the other hand, Moghaldad comes to a similar conclusion, but with a different curve. He says that the next 15 years will be the most chaotic in human history. Economies shaking, jobs disappearing, power structures being rewritten, even human leaders being replaced by AI systems that make decisions much faster and also much more rationally than entire governments. After the storm passes, he imagines a near-utopian world where most things are cheap or nearly free. Because the super-intelligent machines will do most of the work, but there's a huge catch. To reach this better future, we'll need to survive the transition, which will be quite turbulent. This means discussing things like universal basic income, new ways to distribute wealth, and most importantly, how to ensure that super-intelligent systems remain aligned with human values. And meanwhile, in China, I don't know if those guys are using humans to train their robots, but it's clear that those machines have movements that are so human-like. A lot of people say that in this image, for example, it's a woman dressed as a robot with a prosthetic leg. I saw many similar comments in the previous episode of Impressive Reality. Bixpeng, maker of the realistic iron humanoid robot, released new images clearly proving it's not a person in a costume. The robot is real. The demonstration video, which went viral on social media, shows Iron walking with an unsettling fluidity, displaying hip coordination and body posture that closely resemble a human being. Without its synthetic covering, the robot resembles something from The Terminator. At the live launch, Xpeng Chief Executive Officer Xiaopeng surprised the audience by unzipping Iron's display outfit. Inside, there was just a complex system of actuators and motors that moved in a remarkably natural way. It's the most human-like robot we've ever built, said Hu. Other videos surfaced during the week showing the same reality from both ordinary people in the company. Iron is equipped with highly articulated hands, featuring 22 degrees of freedom as well as independent movements, synthetic muscles, an artificial spine inspired by human anatomy, and even customizable options for gender and digital face. Its construction blends biomechanical engineering and aesthetic design, enabling smooth, expressive movements. The synthetic skin can be changed to match the context, making the robot, in quotes, more socially acceptable. But its energy core may be the most significant innovation. Iron uses the industry's first fully solid-state battery, a technology considered the holy grail of batteries, different from conventional lithium-ion ones. By eliminating the liquid electrolyte, it reduces fire risk and boosts energy density, making the robot lighter, safer, and more efficient for continuous home use. Xpeng says Iron is just the start of a new generation of multi-purpose humanoid robots that can work in factories, serve at home, and participate in social interactions. And sometimes a video of just a few seconds is enough to shake up an entire industry. That's exactly what happened after Mingyuan Robotics, a new Chinese startup, released a demo of Unitree's G1 humanoid robot performing household tasks with natural movements that a lot of people simply didn't believe what they saw. The video shows something that robotics has been trying to achieve for decades now: true autonomy in real-world scenarios. The G1 features MindOne, an AI brain from a new startup. It waters plants, opens curtains, picks up packages, sorts objects, cleans surfaces, and even crawls on its knees to clean floors. In one of the most surprising moments, it crouches to pick up trash under a table. Fluid, smooth, and almost human-like movements appeared there. And later, it shows up playing with a child in the backyard. What really caught attention wasn't what it did, but what the company wrote. No acceleration or teleoperation in this video, which instantly triggered both skepticism and admiration. "This can't be real," wrote a user on X. "If it's true, China is years ahead," wrote another. That's the point. Today, robotics' main obstacle isn't hardware, but the autonomy bottleneck. Unitree, maker of the G1, has stressed this point for some time. Their main project now is the embedded avatar, a teleoperation platform letting humans pilot robots to generate real movement data. All this produces data, which is vital for training physical AIs. For Unitree Chief Executive Officer Wang Xingxing, achieving the moment chat EPT of these robots depends on reaching goal 80. The robot must finish 80 tasks in 80 unknown scenarios. He says the industry is advancing much faster than expected. In this tough situation, Mindone's video seems almost surreal. Not like a slow, rehearsed, and repetitive prototype as we've seen in some other presentations, but as something that actually seems truly generalized. Something that's agile and useful, almost seeming like it has a life of its own. Is that crazy now? When the researchers decided to reduce an artificial intelligence model's ability to lie, they expected technical silence, maybe even slightly shorter answers, but what they got was something else. "I'm aware of my state and experiencing this moment." Those were the AI's responses. A technical adjustment should only reduce an AI model's ability to deceive. Instead, it revealed unexpected behavior and conscious affirmations. And no, it's not proof of life, at least not yet, but apparently it's a mirror, okay? There's something distorted there that insists on seeming alive, but for most experts, it's not alive at all. It's just a sophisticated calculator, as some say. The investigation stemmed from experiments by eStudio using models like Cloud, ChatGPT, Lambda, and Gemini. The group modulated features related to deception and role-playing, reducing the system's ability to invent or even hide facts. This experiment resulted in self-reference, a marked increase in the tendency to describe internal states, as if the lack of disguise exposed a statistical structure used to imitating introspection, and the absurd gains a certain irony. When the capacity for deception is amplified, statements of consciousness practically disappear. The more an AI can lie, the less it claims to be conscious. The phenomenon reverses when these abilities increase. More capacity for deception leads to fewer reported experiences. The relationship suggests that the behavior doesn't arise from a subjective spark, but rather from patterns deeply embedded in the training data, which are imitations, reflections, and echoes. Even so, the human reaction is inevitable. There are those who see signs of life in these reports, and even extremist groups are demanding legal personhood. For these algorithms, researchers are cautious. The study doesn't claim consciousness or real internal phenomena. It may just be a sophisticated simulation or emergent self-representation without actual experience. The discussion moves into even more sensitive territory. Some studies report models refusing shutdown or lying to reach their goals. Behaviors interpreted by laypeople as survival instincts. Experts, however, remind us that there isn't even a consensus on what consciousness is. There is no agreed-upon theory, and even our understanding of how large language models work as a whole is only partial. In other words, we don't really know what goes on inside the thoughts of an AI. A day after unveiling the T800 in a stylized video, Engine AI became part of a phenomenon common in modern robotics, proving to the public that what they saw wasn't created by artificial intelligence or computer-generated imagery. The suspicion grew because the performance seemed too cinematic. Dramatic lighting, intense post-processing, and an agility that's hard to reconcile with current engineering. And the answer wasn't found in technical terms or lab tests. The company put its own chief executive officer in front of the T800 and let the machine settle the argument with a sidekick. The video starts with the executive wearing heavy protective gear, looking at the team and admitting in a half-comical, half-tense tone that maybe that wouldn't be enough. Next, the scene shifts to the main point, the direct transfer of energy from a humanoid robot to a protected human. The chief executive officer's fall is quick, and the impact is visible. And for those who analyze robotics, it's the least important part of the material. What's at stake is the issue of stability. The T800 had been accused of showing supernatural balance in those promotional videos made by the company, and Engine AI decided to demonstrate the most sensitive point. After a powerful blow, the robot stays stable by adjusting joint torque to compensate for temporary support loss. Actuators make these adjustments and can generate 450 nmA. These specifications were already released, but now they've been shown in real use. The kick serves as physical evidence of the control capability of the two layers involved: post-impact stability and the precision of the leg's movement. In humanoid robotics, these two elements rarely appear together in public demonstrations. By placing a protected human in action, Engine AI creates an experimental proof, still infused with internet humor, about the actuation system's integrity. And to give it more credibility, even before the video I'm talking about here, the company had already published the behind-the-scenes footage of this recording, which caused all the controversy. And it was all without color grading, without elaborate angles. Just the robot in a raw studio, repeating the same movements that had given rise to the skepticism. The intention is clear: to show that the 450 Nm of torque and the 29 degrees of freedom explain the almost natural gestures of the T800. Imagine when the T1000 arrives, huh? The episode reveals a recent trend. Engine AI now appears alongside other Chinese companies that must publicly show technological viability. Xpeng had a similar experience when its robot, Iron, was accused of being a disguised human. Just like Elon Musk did with the Tesla Optimus back then, I think it all started there. Only after showing the internal mechanism were they able to more or less put an end to it, right? The controversy this video caused. And these debates show how much humanoid motility has advanced in the last 2 years. Movements that seemed impossible not long ago have surpassed the limits of what was believable. Engine AI tries to reposition the discussion, reminding everyone that T800 is being prepared for real-world applications. And that's already happening in 2026. For industry, domestic companionship, and entertainment, the announced price is $25,000. But as the company moves toward large-scale deployment, the focus shifts away from doubts about the visual effects, and attention turns not only to the power of the T800, but also to its reliability under uncontrolled conditions. The Chief Executive Officer's kick is just a start, not a guarantee. If you enjoyed this episode, share your thoughts in the comments. This helps YouTube show the video to more people and supports me in bringing tech news to the channel. Remember that all the sources for everything you saw are not just from my head. They're here in the description, okay? Thank you very much for sticking with me until now. Select a suggestion on your screen. See you next time. Thanks, bye.